Okay, so let's make sure we can do this. So let's try balancing this reaction. And I'll give you your textbook back so you can refer to the steps again if you want to. So you want to start by making sure you have the example copied here. And then the board is getting kind of smudgy. Can you read what I have on the board here? Okay. This should be a 4. I wrote this down wrong at first, but this should be a 4. Okay, well, when you're ready, let's talk our way through how to attack this.
So first you split it into 2.
Yeah, what should those be?
So MnO4 minus goes to MnO2. Plus 4 electrons. Or do you just want us to do that later?
Plus 4 electrons. Now, we don't want to start adding the electrons yet. We have to do things in order, right? If we add the electrons now, we're actually going to get messed up. So we have to do those in the order of the steps that they gave us in the book. And I wouldn't expect that memorized yet. So if you need to, you can refresh your memory of the steps in the book. All right, but let's go ahead and write down the other half reaction as well. What would that be?
Cr2O4 goes to CO3 2-.
All right, we don't need to bother writing the phases here, but you should be very careful to copy the charges. You got to copy the charges correctly or the rest of our steps won't work. Did I get those charges right? I think so. Okay.
So you're supposed to balance the non-oxygen first. So the first one is balanced, but you need to add a 2 on the second one.
Yeah, we start by balancing the elements that are not oxygens and hydrogens. Well, the manganeses here are already balanced, but the carbons are not. It looks like you figured out that we need 2 equivalents of this. Notice that I don't put a subscript 2 here. I can't change the subscripts. I can only change the stoichiometric coefficients. Okay, good.
And then you're supposed to add in the waters, or you add in the waters. So the first one, you want to add water onto the right side.
How many?
2. That's fine. Oh, yeah, 2 of those, sorry.
2?
Yeah.
Yeah. Because now we have 4 on the right and 4 on the left. And again, if this was a real problem, you'd want to be very careful just to double check every step. Because if we make one careless mistake, all the rest of our work will be wasted. Okay, good.
And then and are we going to balance? Okay.
Let's go down to this one too. So what do we have to do down here?
You add water.
On the left side.
How many waters do we need?
No, it's on the right side, right? Because it's 4 oxygens on this side and there's only 3 on the... Oh, there's 6, that's ours.
Yeah, we can't forget about these
So we
six.
need 2 waters.
And now we should check to make sure that's right. On the left side we have 4 plus 2 is 6 oxygens. And over here we have 2 times 3, which is 6. So that's right. Maybe again, we should now, you don't have to do this, but we're now committed to these coefficients here. So that might help us to remember to focus on the stoichiometric coefficients as well. Okay, so I think that's right for, all right. So again, you just have to double check each step. So after balancing the non-oxygens and non-hydrogens, we went on to balancing the oxygens with water. Okay?
Now you add the protons in. So then add 4 protons to the left.
Even though this was basic solution, we're going to treat it at first as if it was acidic, because that's the method that your textbook uses. So if this was acidic, we would put in the 4 protons. Okay, good.
4 protons over there on the right.
And there's 4 of these here and 4 of these here. Notice that right now we're ignoring the charge. We just balance one thing at a time. So to balance the protons, we need 4 protons here and 4 protons here. Does that make sense?
When do the electrons come in?
No.
Now, they come in now. That's right. So first,
Yeah.
so let me,
So you have 3 electrons on the left, on the first one.
so here's the order of balancing. this is in your textbook, but the textbook doesn't quite lay this out on the table. First, we balance the non-oxygen and non-hydrogen elements. Then we balance the oxygens using water. Then we balance the hydrogens using protons. And then finally, we balance the electrons. So we have to leave the electrons for last. And all of these are in the half reactions. This is all stuff that we do in the half reactions. Does that make sense? Okay, so we were at this step so far. All right, so what do we do now after these hydrogens? All right, so let's be careful about that, because that's the step that tripped us up last time. So let's figure out where we need the electrons here.
On the right side, 4 on the right.
How many electrons?
4. Oh, never mind, no. Okay, so it's -8 plus 4, so we have -4 on the...
But it's just plus 3 on the left, right? The overall charge?
Yeah, so let's start with what's the overall charge here so far?
Plus 3.
Yeah, because there's just one of these with a -1. Remember, there's not a separate negative on each oxygen.
Started doing that.
Yeah, again, maybe the fact that we started by doing oxidation numbers might have actually confused us here. So we're not trying to figure out the individual charges on each individual oxygen. Remember that we don't need the individual oxidation numbers to use this method for balancing half reactions. All you need is to know the overall charge on the species. There's just one species here with a -1 charge. So that means that overall, this side had a +3 charge. 4 minus 1 is 3.
And so then you have to have 3 electrons on that side.
So we have to add 3 electrons here, because the right-hand side is neutral. The right-hand side is neutral, so we have to make the left-hand side neutral. Let's make sure that makes sense. Does that make sense?
Yeah.
All right, by the way, remember that when you first did this, your first instinct was that we needed 4 electrons. So I can see why you thought 4 electrons at the start, because you were thinking there was 4 -1s here.
Yeah.
But anyway, notice that we don't balance the electrons until this step. We don't balance it until we balanced all of these. So we have to do these in this order. If the method doesn't work unless you do everything in this order. If we do things out of order, things get messed up. Okay, we're not going to prove why this works, but it turns out this method works and other orders don't work. Okay, so this was right. All right, so let's take our time and figure out the charge where the electrons go here.
2 into the
2 on the left. -4.
So,
No.
No.
Wait, so -4 and +4 is, so it's neutral on the right, right? Neutral on the right, so
Plus,
2 minus on the left. So we need 2 electrons on the right.
Good, that's a good method. What's the charge right now on the left? -2. Because 1 times -2 plus 2 times 0 is -2. And what's the charge right now on the right? Well, 2 times -2 is -4, plus 4 times 1 is 0. So we need to add a -2 here to balance this -2. So we add the 2 electrons over here. All right, and again, this is the step I think where it's easiest to make mistakes. You really have to double check yourself. Good.
So then now we're supposed to multiply to erase the electrons.
Right.
So you multiply
top by
by
2,
3
bottom
and
3.
2.
Yeah, so this is kind of like a little like finding a common denominator. In this case, we have to multiply both of these. So we're multiplying the top equation by,
2,
and we have to multiply the bottom equation
3.
by 3. All right, so what does that give us as our new equations?
2 MnO4 minus
Mm-hmm.
and aqueous.
That's right, although we still don't have to put that in yet because we're just doing the half reaction so far.
Oh, we're not doing them all.
You could kind of skip, but let's do this step by step. Let's just do the new half reactions. So then that's plus 8 H pluses.
Mm-hmm.
What else?
2 goes to...
Plus 6 electrons. And that goes to
2 MnO.
2 MnO2s.
And then 4 H2O.
Plus 4 H2Os. Good. Notice that we're not multiplying these charges. We're just multiplying the stoichiometric coefficients. We can't change these charges or the subscripts. All we can do is fiddle with the stoichiometric coefficients.
Mm-hmm.
All right, and what is the other new half reaction that we get?
3 Cr.
C2O4s. Yeah, so there's no CRs in this problem.
Sorry.
That's okay.
6 waters
Mm-hmm.
goes to 6 CO3 2 minus
Mm-hmm.
12H plus and 6 electrons.
Okay, very good.